Yes, good evening everyone. Yesterday we have discussed about relative velocity and how to find out the magnitude and direction of it, isn't it? Yes, today we will be discussing for relative velocity of rain with respect to man. Okay, so here we are discussing today about relative velocity applications, as I said yesterday. So the applications, one of the application is nothing but where we have to apply relative velocity. Yes, we did with relative velocity yesterday itself. So where to apply? Okay, so how to apply this one, where to apply, in what situations we have to consider for relative velocity. Okay, so now here let us imagine just you are moving in a rain, so rain is falling vertically downward and you are moving on road. So here the thing is you have to hold umbrella, isn't it? So that you have to save yourself from the rain. Okay, so here the thing is you have to save yourself from the rain. So in what direction? In what direction from the vertical you have to hold the umbrella? So that we have to study today. Okay, so that is what, if we know the what is the relative velocity of rain with respect to man, we can go for where to hold the umbrella, at what angle from the vertical we have to hold the umbrella. So here is the topic today, that is nothing but relative velocity, relative velocity of rain with respect to man. So here our concept is relative velocity of rain with respect to man is, before going to study anything we should know why we have to study about this. And as I said yesterday, relative velocity, so how we are, where we have to use the applications, where we have to use the relative velocity, those are nothing but the applications. Okay, so here one of the application is nothing but the relative velocity of rain with respect to man, that we are going to study today, isn't it? Yes. Coming to the point, let us imagine that a man is moving towards east. Let us imagine a man is moving towards east. Okay, so let me put the directions over here. Yes, a man is moving towards east. Let us take the case here where the man is moving towards east. Okay, so let me put the directions. Or you can imagine yourself. You can imagine yourself that you are moving towards east, and now this will be west, this will be north, and coming to the south here. Okay, yes. So what I am saying is there is a man, otherwise imagine yourself in place of man who is moving towards east. Yes. Now yes, as man is moving towards the east, as he is moving, he should possess some velocity. What is the possessed velocity? What is that possessed velocity by man? That is nothing but, let me consider, the man is moving with a velocity vm towards east. Okay, so now here the rain is falling, isn't it? The rain is falling vertically downward. So the rain is falling vertically downward means what? So this is what, where this is what, towards east, the direction of man. Okay, so man is moving towards east with the velocity vm, and now the rain is falling vertically downward like this. Yes, the rain is falling vertically downward. So now let me take here where the rain is falling vertically downward. Let us take Vr as the velocity of rain. Vr is nothing but the velocity of rain with which it is falling vertically downward. Okay, now. So yes, it is east, west, north, south, isn't it? So now coming to next point here. Here, what we want to find out is, here the man has to hold his umbrella so that he should save himself from the rain. Okay, so he should not get wet by the rain. So now, at what direction he has to hold the umbrella? Here the thing is, man is moving here. Okay, man is not at rest. Man is moving, and also rain is falling vertically downward. It is also having some velocity. Man is also having some velocity, isn't it? Now, so there will be resultant. So here, to find out what is the relative velocity of rain with respect to man. To find out what is the relative velocity of rain with respect to man. What to do? I say yesterday how to find out the relative velocity. We have to make one component as, otherwise one velocity or one body at rest. So here that can be done by impressing the velocity minus Vm to both the man and rain, isn't it? To both the man and rain, isn't it? So this is what the direction of man, here where the rain is falling in this direction. And now to find out the relative velocity, I have to put the vector minus Vm. Otherwise, I can say here, if we want relative velocity of rain with respect to man, rain with respect to man means that man's velocity we have to reverse in order to find out the relative velocity of rain with respect to man. Okay, so now coming to the point, so here I have reversed the direction, otherwise I can say I have impressed the velocity Vm for both man and rain. So now here you have to consider these two things now. So here you have to consider velocity of man and velocity of rain like this, isn't it? So here now, if these two are the vectors acting, where will be the resultant? Let us imagine here where somewhere in between these two vectors the resultant lies, isn't it? So let me put this vector as the resultant vector due to these two vectors. Now, so here this is what relative velocity of rain with respect to man. This is what relative velocity of rain with respect to man. Here where it is acting due to these two velocities, isn't it? So now let me take, this is making an angle, this is making an angle theta. It is making an angle theta with the vertical, Remember, I have considered angle with the vertical. I am considering the angle with the vertical. If theta is the angle made by the relative velocity of rain with respect to man with the vertical. Okay, so then let me extend this backward. Let me extend this backward like this. Yes. Okay, now. Here the angle will be same, that will be theta, isn't it? Yes. So now it is to find out what is the magnitude of relative velocity of rain with respect to man. Why we are finding that? Why? Because we want to, otherwise the man has to save himself by holding the umbrella. At what angle he has to hold the umbrella, and what is the magnitude of that velocity, resultant velocity? What is the magnitude of that relative velocity of rain with respect to man? We have to find out now. So what is the magnitude of this vector, and along with that, at what direction it is acting? So we want theta as well as magnitude of this VRM. Okay. So now for that, what we will do is you have to use parallelogram law of vector addition, and you know that by using that, resultant of two vectors can be given as resultant of two vectors. That means here I want magnitude of VRM. So here I want magnitude of this relative velocity. Magnitude of VRM can be written as under root of yes, VR square plus Vm square. What are the two velocity vectors you can see? Vr and Vm, isn't it? So Vr square plus Vm square plus 2 Vr Vm cos What is the angle between those two vectors? You can see. What is the angle between those two vectors? That is VR and VM. Angle between these two is nothing but, yes, this 90 degree. You can say angle between VR and VM is nothing but it is 90 degrees. So shall I write 90 over here? Yes. I think all of you have got. Nothing I did here. We have used parallelogram law of vector addition to get the resultant of two vectors. So of these two vectors VR and VM in this direction. Now, what you can write now by using this? That is VR square plus VM square plus 2VR VM cos 90. Cos 90 is nothing but 0. Okay, so now what you can write in next line, that is equals to VR square plus VM square, that is plus 0. So what we will get? 0 into 2 VR VM is nothing but 0. So we left with the magnitude of VRM, that can be written as magnitude of vector VRM is nothing but under root of VR square plus VM square. Yes, here successfully we got what is the magnitude of that relative velocity of rain. Relative velocity of rain with respect to MAM is nothing but under root of VR square plus VM square. Okay, so I hope all of you have got. Nothing we did. Man is moving towards east. Rain is falling vertically downward. So man velocity is Vm. Rain velocity is Vr. With respect to what? With respect to ground. Okay, so now here we want velocity of rain with respect to man. We want velocity of rain with respect to man. So here, for that, what I can do? I can reverse this vector, vector Vm in this direction. So that is minus vector Vm. So why? Because to get the resultant. Okay, so now here what you will do? So yes, if these two are the vectors acting, means somewhere in between these two the resultant will be there. So let me take this relative velocity of rain with respect to man vector lying at an angle theta with the vertical. Okay, let theta be the angle with the vertical. Okay, so now we are using parallelogram law of vector addition to get the magnitude of that. Okay, that is magnitude of relative velocity of rain with respect to man. That is VR square, VM square, 2VR VM cos 90 degree. Okay, so angle between those two vectors, angle between these two, what here, which angle you have to write over here? You have to write the angle acting between those two vectors. Okay, now, so now here we have simplified for it and we got magnitude as under root of VR square plus VM square. Yes, now it is time to get the value of direction. How to find out the direction? Let me take here the direction as theta. Okay, you can take it as alpha beta anything. If you are taking this angle with 90 degree as theta means you can take it as alpha beta. I have taken directly the angle made by the resultant vector as theta with the vertical. Okay, so now here if you are keeping theta here, you have to replace it by alpha beta anything, any angle. Okay, so now here we have to find out what is the direction. So what is the direction that vector, resultant vector has made with the vertical? With the vertical. Remember, with the vertical. Okay, so now finding for that, what you can do? Yes, theta can be written as, for finding theta, I can get tan theta is equals to, I can put tan theta is equals to, so tan theta is nothing but for this theta, wherever theta is there, opposite side, it will be opposite side, isn't it? So opposite side to this will act as a opposite. So this is what? Opposite, and here it will be adjacent. So opposite divided by the adjacent side will be giving you the value of tan theta. So now what is the value of this opposite side? That will be equal to this. Okay, so that is what? Vm. So this is nothing but Vm. So put the value as Vm divided by the adjacent is nothing but Vr. So here you can write down theta as theta is equals to tan inverse of Vm divided by Vr. I said you already by using logarithm how you can write, how you can find out the value of any angle. Okay, so now this is how we have to find out the direction, and we did with magnitude and direction. Okay, so now here what actually you got by doing this? What actually you got by doing this means here I have to, here our purpose is to find out at what angle with the vertical, at what angle with the vertical, the man has to hold the umbrella so that he has to save himself from the rain. That means at an angle of this much, tan inverse of Vm by Vr, they will be giving you the value of velocity of man. Okay, so velocity of man and velocity of rain, they will be giving you these two values, and you can easily find out the value of theta. And what is the magnitude of that relative velocity by using this under root of Vr square plus Vm square. I hope all of you have got this one. So here the intention is at this angle from the vertical, at angle theta, okay, which is equals to tan inverse of Vm divided by Vr at this angle from the vertical. If man is moving like this, rain is falling like this, means from the vertical he has to hold his umbrella. From the vertical he has to hold his umbrella by making an angle theta. So at this much angle, okay, he has to hold his umbrella so that he can save himself from the rain. Okay, so now this is what about the theory, and now we will move to the numerical so that you will come to know how to solve rain man problem. Okay, so now moving to the numerical. Yes, be ready to solve the numerical. Now, yes, listen here. We have got a numerical related to rain man problem. Yes, the question is a man is going due east with a velocity of 3 km per hour. Let us go for the first question. A man is going, a man is going due east with a velocity of 3 km per hour, with a velocity of 3 km per hour. Okay, so now rain falls vertically downward. So rain falls, try to understand the question. Rain falls vertically downward with a speed of 10 km per hour. With a speed of 10 km per hour. With a speed of 10 km per hour. Okay, so now find the angle. Find the angle. Yes, you see what they are asking. Find the angle. Find the angle at which he should hold his umbrella. Find the angle at which find the angle at which he should hold his umbrella. Okay, he should hold his umbrella. Okay, so try to understand the concept where we can apply this relative velocity. Okay, hold the umbrella so as to save himself from the rain. So as to save himself. So as to save himself from the rain. Okay, so look at the question. Yes, this is what the question you have now. Okay, so now a man is a man is going due east with the velocity of 3 km per hour. Try to understand the question. A man is going due east with a velocity of 3 km per hour, and now rain is falling vertically down with a speed of 10 km per hour. Velocity of rain is given, that is 10 km per hour. Okay, now they are asking to find out the angle, okay, at which he should hold his umbrella so as to save himself from the rain. Okay, so now here we have to solve this by taking first by considering the given data first. What they have given? They have given that a man is moving due east with a velocity 3 km per hour. So let me put the diagram for this again. Same thing, same diagram you will get. Here also man is moving towards east, and now rain is falling vertically downward. Okay. Okay, you see here, man is moving towards east, due east with a velocity of 3 km per hour. So here what they have given, velocity of man is nothing but 3 km per hour due east they have given, isn't it? So now, next what they have given, and the rain is falling vertically downward with a velocity of 10 km per hour. So velocity of rain is nothing but 10 km per hour. It is understood that downward direction. Okay, now, so let me take here where the man is moving, here where the man is moving due east, and the velocity of man is nothing but Vm is equals to 3 km per hour. And now the rain is falling vertically downward. The rain is falling vertically downward with a velocity of Vr is equals to 10 km per hour, isn't it? So this is what given value, and they are asking you to find out the angle, okay, at which he should hold the umbrella. Okay, so now, so for that we should need first what is the relative velocity of. That means I am giving you just a hint. So that means how you can write it. They are asking for magnitude. Here they have asked for angle. So let me write this equation first. So velocity of rain with respect to man is nothing but velocity of rain plus of velocity of man. Okay, now this you know, relative velocity. I have given just the formula. Yes, now here we have to find out. Here we don't want magnitude. Here we have to find out the angle. So yes, what I have to do first thing is to reverse the velocity of man in this direction. So minus Vm, I have to impress on both man and the rain, this vector, isn't it? So I have to reverse the velocity of man to get the relative velocity, isn't it? So now where it should act here, let us take the resultant velocity will be here somewhere like this, making an angle theta with the vertical. So I can write it as velocity of rain with respect to man. Okay. So now here our intention is to find out the value of theta. Here our intention is to find out the value of theta, isn't it? Yes. Now what we have the formula, what we had the formula as. Yes, we have found. So theta is nothing but here it can be written as Vm, and here it will be Vr, this much. Okay, so now what I can write now for theta? Tan theta. Tan theta is equals to, what was the formula? Just look at that, Vm divided by Vr, Vm divided by Vr. Okay, so now what is the value of Vm? They have given 3 km per hour. So let me write down Vm as 3. Both are given in terms of kilometer per hour. So just write down the magnitude 3 divided by Vr is nothing but the 10 km per hour, 3 by 10. Okay, so now what you can write, 3 by 10 is nothing but 0.3. Tan theta is equals to, yes, take out the log table and find out the value of tan theta is equals to 0.3 means what is the value of theta. So theta is nothing but theta is equals to tan inverse of 0.3, and if you search for it, if you find out the exact value means I can imagine that you are perfect with the logarithm table. Yes, you should get tan inverse of 0.3 as 16.7 degree. 16.7 degree, just verify. So tan inverse of 0.3. If you have got tan theta as 0.3, check out in the log book. Theta will be equal to 16.7 degree. Okay. So now this is how you have to find out the angle. Okay, in Rayman problem. Okay, now coming to next one. Let us move to next problem. I hope all of you have got this. Okay, try to understand what is Vm, velocity of man. Okay, already it is given means velocity of man with respect to ground. If I write VRM, velocity of rain with respect to man means velocity of rain with respect to ground and velocity of man with respect to ground. You have to write like that. Okay. So now velocity of man with respect to ground is 3 km per hour and rain with respect to ground is 10 km per hour given. And now result, you know that relative motion formula, relative velocity of rain with respect to man, it can be written as velocity of rain and velocity plus of minus velocity of man. We have to reverse the direction so as to get the resultant. So here, and we got tan theta. We know that tan theta formula is nothing but Vm divided by Vr. Vm is nothing but 3. Vr we have got 10. 3 by 10 is 0.3. Tan theta is 0.3. Take out your log table and check the answer for this. You have got 16 point. You should get 16.7 degree as the answer. So this is how you have to find out the angle. If they are asking to find out magnitude, what you will do for finding the magnitude? I said you already. What is if they are asking you to find out the magnitude of relative velocity of rain with respect to man? How you will do? That is equals to under root of Vr square plus Vm square. That is equals to under root of Vr square plus Vm square. Substitute the value of 10 square Vr and Vm you can write down. Vr is nothing but 10 square, Vm is nothing but what? 3. You can go for it. It is 100 plus 9. So under root of 109 you can write down. Okay. So this is how you can solve the numerical. Okay, now moving to next question. Let us go for the next question in relative velocity. So here now I am giving just not Rayman problem. One I would like to solve on relative velocity, not particularly on Rayman problem. Okay, relative velocity between acting between two bodies, that is in two dimension. Relative velocity in two dimension. Okay, now yes. Let us go for the second question. Question number 2. Based on relative velocity, not on Rayman problem, based on relative velocity. Okay, in 2D. Now, look at the question. A particle P is moving along a straight line. They are saying that a particle P is moving along a straight line. Okay, here you see. A particle P is moving along a straight line now with a velocity of 3 meter per second. With a velocity of 3 meter per second. Okay, and now, and another particle Q has a velocity of 4 meter per second. You see, and another particle Q has a velocity of 4 meter per second. Another particle Q has a velocity of 4 meter per second. Okay, so now at an angle of 30 degree to the path of P. Look at this question. At an angle 30 degree at an angle 30 degree to the path of P. Okay, so now find the speed of Q relative to P. They are asking you to find out. Find the speed of, look at the question. Find the speed of Q. Okay, find the speed of Q relative to P. Relative to P. Yes. Read the question properly. Now, here in the question they have given that a particle P is moving along a straight line. So let us take a particle which is moving along a straight line. Yes, let me consider. A particle is moving along a straight line. Okay, so now that particle is nothing but P. So let me name it as P. Yes, P is moving along a straight line. And now with the velocity of 3 meter per second. So here the velocity is nothing but 3 meter per second. Velocity with which the particle P is moving is nothing but Vp is equals to 3 meter per second. And another particle Q has a velocity of 4 meter per second. They are saying that another particle is there which is moving with a velocity of 4 meter per second at an angle 30 degree to the path of P. At an angle 30 degree, yes, see, another particle is there which is also moving by making an angle 30 degree like this. So let me take at an angle 30 degree to the path of P. This is what an angle 30 degree with the path of P. Okay, the particle Q is moving. Okay, so that velocity of that particle Q is nothing but velocity of Q is nothing but 4 meter per second. Okay, and now what they are asking, find the speed of Q relative to P. They are asking you to find out the speed of Q relative to P given velocity of P. How much? 3 meter per second. Velocity of Q 4 meter per second. Okay, now what they are asking? They have given angle is 30 degree. They are asking you to find out the speed of Q relative to P. They are asking you to find out speed of Q relative to P is nothing but velocity of Q with respect to P is nothing but how much. So here they have not given the direction, velocities you will just write down. Okay, velocity of Q with respect to P they are asking. I hope all of you have got. Now here, what we have to do to find out the relative velocity? Yes, the thing is we have to reverse. We have to make the body P at rest. Why? Because with respect to what we are finding with respect to P. So let us reverse the velocity of P. That is nothing but minus Vp will be in this direction. We can take it as PQ. Let me take here O. And now, so that is what you can take it as P dash like that. Okay. So now, here the thing is they are asking you to find the speed of Q relative to P. They are asking. So here I have reversed the direction like this. Okay. So now where should be the resultant of this vector and this vector should lie? Where should the resultant of these two vectors should lie? Okay, where? Somewhere over here you can imagine. Somewhere over here. Oh, I have to make perfect parallelogram, so let thinking of it. Yes. Now, this is where the resultant is acting. Okay, so let us take this as velocity of Q with respect to P. This vector, resultant vector. Okay, now you can see over here, if this angle is 30 degree, we know that the angle between P dash and P is nothing but this much is 180. So this whole thing is 180 degree. And if here it is 30, here it is 180, what you can write for the angle between these two, Q and this Vp, reverse direction of Vp, what you can write? That can be written as here this one. 180 minus 30 is nothing but it is 150. 180 minus 30 is nothing but it is 150. Okay, so here I have to find out the speed of Q relative to P. VQP I have to find out. So for that what I can make it as a parallelogram. So make it as a perfect parallelogram. Okay, so here it is little bit deviated. You have to understand. Okay now. So what I can write for VQP now? What is the magnitude of VQP? You know that. Magnitude of any vector. Okay. Resultant magnitude of resultant of two vectors can be written as VQ square VP square plus 2 VQ VP, and what is the angle between those two? Cos of that one, that angle, cos of 150. So write down. Here our intention is to find out the magnitude of this vector, relative velocity of Q with respect to P. So it is what? It is the resultant of these two vectors. What those two vectors? VQ and the reverse direction of VP. Why we have to take reverse to get the resultant over here, VQP. So now, what is that modulus of VQP? That can be written as VQ square plus VP square plus 2 VQ VP cos theta can be written as directly cos theta. If you want, you can write down. Cos theta is nothing but 150. Look at this. Angle between those two vectors is 150. Okay. So now, write down what you can write. VQ square. VQ square is nothing but 4 square. VP square is nothing but 3 square plus 2 into 4 into 3 cos 150. Cos 150 can be written as, yes, sin 90 plus 60. Sin of 90 plus 60 is nothing but sin 60 minus sin 60, that is nothing but the root 3 by 2. I can write it as minus root 3 by 2. Okay, so take the values, solve for it, simplify. So 4 into 4, 16, 3 square, 9. So what is this? 24, 2 into 4, 8 into 3, 24. Here, let me write down minus. Okay, oh, after that, you can write, otherwise 2 you can cancel here only. Root 3 by 2. Okay, so let me cancel here only. 2, here we left with 12 root 3. 12 root 3. Isn't it? So what is 16 plus 9? It is nothing but 25 minus 12 root 3. So solve for this. How much you will get after solving? Your answer should be under root of 4.216. Your answer should be solved for this. Under root of 4.216. So this will result in 2.1. As it is a velocity, you can put the unit as meter per second. So magnitude of relative velocity of Q with respect to P is nothing but 2.1 meter per second. I hope all of you have got the answer. Go for 12 root 3 and afterwards 25 minus 12 root 3. Take root of 4.216, will get 2.1 meter per second. So this is how you have to find out the relative velocity of one body with respect to another body. Okay, in 2D motion. Okay, so now moving to next now. Let us go for next question. Yes, see. A boat is, question number 3, a boat is moving with a velocity of, going for question number 3. Here the question is, a boat is moving with a velocity, they have given, a boat is moving with a velocity What is that? 3I cap plus 4j cap. 3I cap plus 4j cap. Okay, and now with respect to the ground, with respect to ground. Okay, now the water in the river is moving with a velocity. The water in the river, the water in the river is moving with a velocity. Try to understand the question. The water in the river is moving with a velocity. Yes, minus 3I cap minus 4j cap. Minus 3I cap minus 4j cap. Okay. So now, with respect to the ground, they have given with respect to ground. See what they have given. Okay. Now, what is the relative velocity of boat with respect to river? They are asking to find out what is the relative velocity of boat with respect to river. What is the relative velocity of boat with respect to river? Yes, they are again asking for relative velocity. Look at the question they have given. Yes. Here they have given a boat is moving with a velocity of 3I cap plus 4j cap. Let me write down the velocity of boat. Velocity of boat is nothing but 3I cap plus 4j cap. Okay. And now with respect to ground, it is velocity of boat with respect to ground. Now the velocity of water in the river is moving with the velocity. The water in the river is moving with the velocity minus 3I cap minus 4j cap. So let me write down. The water in the river is moving with the velocity of minus 3I cap minus 4j cap. Okay, now with respect to ground, both are with respect to ground, measured with respect to ground. Now, what is the relative velocity of boat with respect to river? They are asking to find out what is the relative velocity of boat with respect to river means with respect to water. Both are same. With respect to river, with respect to water, both are same. Okay. So what is the velocity, relative velocity of boat with respect to water? Okay. So now we know the formula for relative velocity of one body with respect to another body. So relative velocity of boat with respect to water can be written as velocity of boat with respect to ground. Okay. So plus of minus velocity of, or you can write down VB minus of VW, or you can write down easily here only velocity of boat with respect to ground and velocity of water with respect to ground. Okay, so here put minus velocity of boat with respect to ground minus velocity of water with respect to ground. Okay, so now what you can write here, velocity of boat minus velocity of water with respect to ground is nothing but VB minus VW. So what is the value of VB? VB is nothing but 3I cap. 3I cap plus 4j cap. 4j cap. Now minus what is velocity of water? So now velocity of water with respect to velocity of water with respect to what? With respect to ground is nothing but minus 3I cap minus 4j cap minus 3I cap minus 4j cap. Okay. So now solve for it. What you will get? 3I cap plus 4j cap plus 3I cap plus 4j cap. So what is the answer you have got here? 3I cap plus 3I cap is nothing but 6I cap plus 8j cap. So this is what the velocity of boat with respect to water, which you have to get. Okay, so this is what you are asked to find out velocity of boat with respect to water is 6 I cap plus 8 j cap. Okay. So now we know that relative velocity of one body with respect to another body can be written as relative velocity of A with respect to B is nothing but velocity of A minus velocity of B. That means plus of minus you can write down. Do not get confusion. So this will be usually measured with respect to ground. Okay. So this is what most important formula you should remember. Okay, so this one. Okay, yes. Okay, now if you have any doubt, you can ask.
Right? In relative velocity, say whatever the concept it might be, velocity of A with respect to B, or velocity of boat with respect to river, or whatever the concept it might be, velocity of A with respect to B, I can write as velocity of A minus velocity of B. Whatever the concept it might be, whether it is river water, whether it is rain and umbrella, whatever the concept it might be, try to understand velocity of one body with respect to another. How we can write velocity of A with respect to B, right? So what can I write? VA bar minus, I can write it as plus of minus b bar, right? So what do you mean by this? Plus of minus b bar. What do you mean by this minus b bar? It's a negative vector. It's a negative vector. For example, whenever if I consider VB direction, for example, I consider in some direction, north, south, east and west, right? So VB, if I consider it as east direction, for example, now in the question what we have, in the formula what we have, minus of VB. What do you mean by that minus VB? That indicates the negative direction of that VB. So we have to reverse the direction. Why we have to reverse the direction? Here minus is there in the formula, right? So based on that minus, we have to reverse the direction by 180 degrees. Whatever the concept it might be. For example, velocity of boat with respect to river, for example. I can write it as velocity of the boat minus velocity of the river. So now what we have to do? The velocity of the river direction we have to reverse. Why we have to reverse? So this is again we have to write in terms of vector addition, but it should be minus times of VR bar. For example, velocity of the river is in this direction. Velocity of the river. Now what we have to do? Minus we want according to the formula. We are standing with respect to what? Velocity of the boat with respect to river. So this direction definitely should be reversed. Minus VR bar we have to consider. Right? This is again vector addition. But minus is there. With respect to that minus, what we have to do? We have to consider the negative vector of anything, whether it is car and road concept, or whether it is boat and river concept, or whether it is rain and man concepts. For example, rain man concepts VRM, velocity of the rain with respect to man. I can write as velocity of the rain minus velocity of the man. So minus, what do you mean by that? So VR bar plus of minus VM bar. So again minus. So if man is walking in that direction, what you have to consider? You have to consider the opposite direction, right? So whatever the concept, try to remember negative vector we have to consider. So you have to take in the opposite direction, right? Okay, right? So equation of trajectory. So it is a little max oriented question, but okay. What do you mean by a trajectory? For example, consider a point, right? So if I consider a straight line, so what is the equation of a straight line? Yes or no? So that is nothing but a trajectory. For example, if I consider a straight line which comes from the origin, which started from the origin, what is the equation of this? Y, which is equals to mx plus c, but intercept is 0. Why? Because the equation or the graph started from origin, right? So if it is a straight line which passes from the origin, what I can write? Y equals to mx plus c, where c value, it depends on the intercept, positive intercept or negative intercept, or it started from origin, right? So now every graph is having an equation. Every graph is having an equation. Y equals to mx plus c is the equation for this curve. So according to the projectile, we have a graph. Yes or no? According to the projectile, we have a graph. We have a graph. What is that? So along x-axis and along y-axis. So what we did? So we projected a particle with a velocity u, making an angle theta. Yes or no? We projected a particle making an angle theta. What happened? We got a curve like this. We got a curve. What do you mean by trajectory now? Trajectory is nothing but how the curve behaves. If it is a straight line, y equals to mx plus c. This is like a parabolic equation, right? So what is parabola expression? Y equals to ax minus bx square. So what is this y equals to ax minus bx square? That will gives you the nature of the curve. That nature of the curve is called as trajectory. The nature of the curve we call as trajectory, right? So y equals to ax minus bx square is the general format of a parabola equation, right? So if a parabola trajectory is there, this format we have to get. If it is a circle, x square plus y square equals to 1. If it is parabola or if it is hyperbola, x square by s square plus y square by b square equals to 1. Different equations will be there, right? What are those? Those are the trajectories which will give you the type of the curve. If it is parabola, this one. If it is hyperbola, something. If it is a circle, x square plus y square equals to 1. So if it is straight line, y equals to mx plus c. All these equations which represents the trajectory of a particular graph. Right? So now here I think we derived this and finally we got the expression in this format. So that's why we call it as the trajectory of a projectile is a parabola. We proved that. After proving, we said it is a parabola. All right? Is that clear?